Registers are small blocks of volatile memory. When the power is switched off on the computer, anything inside registers, like RAM, will be lost. They store temporary values. So as instructions are being run on the CPU, they will create intermediate values. These intermediate values are then stored in registers so they can be accessed quickly. Anything inside a register can be accessed at the same speed as the CPU can run, whilst anything in RAM, there will be a short delay while it's being fetched into the CPU. So registers are fast and run at the same speed as CPU, so they have a clock speed the exact same as the CPU. There are some registers which are special, known as special purpose registers, and they have specific purposes which could only be used for that specific purpose. And we're going to be looking at some of those special purpose registers now. So the fetch, decode, execute cycle is essentially how we get instructions from RAM into the CPU. That process of getting it from RAM to the CPU is known as a fetch. And then once we have the instruction inside the CPU, we need to decode it, work out what the instruction should be, and then finally we can run it and actually do what the instruction has to do. At the start of the FDE cycle, our program must be already in RAM. Remember, storage devices are slow, so we would have had to load the program up into RAM first. This is why, when you first load a program, it will take a little while. The reason for that is we have a slow storage device and we are copying the main code, all the files and all the bits and bobs that the program needs into RAM so we can actually start using it. The program will be located somewhere in RAM, and that location is known as a memory address. Every program, every instruction in the program, and every bit of data that program uses will have its own unique memory address. And this is simply a number starting at 1, going up to however much RAM you have in your computer, measured in bytes. So in order for our program to work, we have to have it in RAM, as we've already stated. The location of that program will be known as a memory address. Now the program is going to be made of multiple individual instructions, and each instruction will have its own unique memory address, as we've already stated. The diagram on the screen, as you can see, is made up of 1, 2, 3, 4, 5, 6 instructions. Each one of the instructions, you can see, have got their own address. Now these addresses are actually not important. What is important is that they have a unique one for each instruction. In order for the fetch, decode, execute cycle to work, we need to use these addresses to say, okay, this is the instruction I want to fetch, or this is the bit of data I want to fetch. So we use addresses as part of the FDE cycle. The first special purpose register we're going to look at today is the program counter. The program counter has the purpose of always pointing to the next instruction we need to fetch from RAM into the CPU. It will have a number, an address, and that address will initially point at the first instruction of our program. So if that program was maybe Word, then our program counter will point at the first instruction for Word. The first instruction must be moved into CPU or fetched into CPU, which is a more accurate way of saying it. The program counter will have the address of that first instruction. And the process of moving the instruction into CPU is known as a fetch. As you see, we fetched the instruction into it. So once the instruction has been fetched into the CPU, we have the process of actually working out, well, what do we need to do with it? That process will turn the binary value of the instruction into a meaningful operation is known as decoding. So we code every instruction that the CPU understands into binary. We give it a binary value. Each instruction has its own unique binary value, so we can tell the difference. Decoding will undo that process by turning the binary back into a meaningful instruction. For example, like adding 5. Once we have decoded, we're ready to run the instruction. Now the instruction will run inside the CPU, and the result of that instruction will be stored also in the CPU inside a register. So for example, we have add 5. What add 5 will do is we'll take whatever was in the accumulator, the special purpose register called accumulator, and add 5 to it. So if there was 5 there already, we add another 5, we would get 10. The accumulator is a special register which is used to store the result of all calculations, including logic calculations. So we've looked at 2 registers already, program counter and the accumulator. There are 2 others that we want to introduce. We have the MAR, which stands for Memory Address Register, and the MDR, which stands for the Memory Data Register. The program counter will always point to the next instruction. MAR will store the instruction of the address of the instruction we're about to fetch. And finally, the MDR will store the result of a fetch. So when the instruction or data has been sent from RAM in CPU, it will automatically go to the MDR before being used further. So now's a good time to pause and make some flashcards because there was a lot of content there. Your flashcards should include what is a register? What do we mean by the term fetch? What is the role of the 3 registers we have just talked about?